Okay. All right, now we're to the part that's probably one of the hardest parts on the thing, and I was really pleased everyone did really well on this on the test. Solving the equations. And first off, we start with a fairly simple one. 2 sine x plus the square root of 3 equals 0. And basically, it's just like solving the equation. If it was 2x plus the square root of 3, what would you have to do to solve it first? You would just simply what? Minus what from each side? Square root of 3. So then you would have 2 sine x equals negative square root of 3. And then you would have to what? Divide by 2. So where does sine x equal negative square root of 3 over 2? And then I would go to your unit circle. First off, this answer is just a negative answer. And where does x equal negative square root of 3 over 2 at? It would be, what's that in quadrant 2? No, it's sine. Sine would be quadrant 3 and quadrant 4. I'm looking, sine is the same as which letter? On the unit circle, it's y. So where's y negative square root of 3 over 2? In quadrant 3 and 4, but it's actually negative at what? Is it pi over 3s or pi over 6s? It should be pi over 3s. So that would mean in quadrant 4 your answer would be what? 4 pi over 3. And in quadrant 5 it would be what? So the x is actually equal to 4 pi over 3 and 5 pi over 3, because that's where y is what? Negative square root of 3 over 2. Now then, problem number 42 is probably the most difficult one on here. I'm going to actually do 43 first so we can see kind of a little more about how to work 42. 43 I'm going to work a lot like this one except for one difference. I'm going to start out with this sine squared x minus 1 is 4 times it equals 0. You would what? Add 1, right? And then you would divide by what? 4. So that sine squared x equals 1/4. And because it's squared, then I have to what? Square root it. And if I square root this, I will get sine x equals plus or minus, because a negative times a negative still makes a positive answer, right? What is the square root of 1? 1. And what's the square root of 4? 2. So 1/2. So now I'm looking for values where sine x is equal to 1/2. Go to my unit circle. It's positive 1/2 at pi over 6 and 5 pi over 6. But sine is also negative 1/2 at what? 7 pi over 6 and what? 11 pi over 6. So this particular answer has what? Not one answer, but what?
2.
Not even just 2. It has what? 4 answers. Because you have sine's positive twice, and it's also negative what? Twice. So you have to have the both positive answers and the both negative answers. And I made a mistake. This is not the answer to number. This is actually the answer to what?
2.
22. All right.
I forgot the other. So
now let's go do 42. The reason I did this one first is because what does each of these have in it? A squared, but it also has parentheses. This is like a quantity factor. All you do is set each one of these equal to what?
0.
So basically it's 3 cotangent squared x minus 1 equals 0, or cotangent squared x minus 3 equals 0. So let's solve this side first. You would what? Add what? 1 and divide by what? 3. So that gives you cotangent squared x equals 1/3. And here's where people will mess up. Now you have to what? Square root. So cotangent x will be plus or minus. What's the square root of 1? 1 over square root of 3. Now I always talk about rationalizing, except this is the one time I'm not going to, because my final answer isn't 1 over square root of 3. I need to find when x equals it. Now cotangent is which letters? X over y. So I'm looking for when x is what? 1, and y is what? Square root of 3, except there's no 1s or square root of 3s, but there will be what? Because what would happen to the 2's on the unit circle when you put those together? They what? Cancel out. So where is x 1/2 and y square root of 3 over 2? So as you look at your unit circle, where does that occur? Where is x 1/2 and y square root of 3 over 2? I believe that occurs at what? Pi over what? 3. And here, that's the positive answer, yet I can have positive or what?
Negative.
Negative. So it's going to occur then at 2 pi over 3, 4 pi over 3.
And 5 pi over 3.
So first off, I need to come over here, and I'm going to have pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, and am I done?
No.
Because I still haven't done what?
The
The other one. Well, I'm going to do it the same way. This time I would just what? Add what to each side? Add 3 to each side. Right, kind of small so it all fits on here. And then you would have to what? Square. Here's the one people will miss. And it will be plus or minus the square root of what? 3. But I don't have two values for cotangent x over y. So what would I do? Put it over what? No.
1.
Square root of 3 is the same being over what? 1, right? So now, cotangent is still what? X over y, but instead of x being 1, it will be what? Square root of 3, and y will be what? 1/2. Which means the values just what? Flip-flop, really, didn't they? So that's going to occur at the what? Pi over 6, 5 pi over 6, 7 pi over 6, and what?
11.
So this one, because it was squared, this one answer had 4, and this one answer had 4, giving me a total of what? 8 what? Answers. Now, yeah, I would be pretty lenient on this one, because technically, what is the period of cotangent? It's not 2 pi, but what? 1 pi. Because if you take pi over 3, and you add 1 pi to it, what do you get? 4 pi. And if you take 2 pi over 3 and add 1 pi to it, what do you get? And if you take pi over 6 and add 1, and 5 pi over 6 and add 1, those answers. So technically, if you're looking to go around the circle the first time, you could have also put those with the plus in pi. I did not put the plus 2 in pi on these, or plus 2 in pi on those either. I said on the test I wasn't going to test that particular. I was just looking for answers in that first go round. All right?